Hey everyone, I'm Prashant. I'm a software developer, a platform engineer, and I work primarily around cloud, Kubernetes, DevOps, and software infrastructure. Along with that, I have also worked on web development, including backend development, building and working with APIs, and some front end development. Over the last few years, I had the opportunity to work on real world applications and I understand not just how they are developed, but also how they are deployed and run in real world environments. So, in this series, rather than just teaching you definitions and theory, I want to show you how the web actually works, how the front end, back end, APIs, databases, and servers all fit together, and eventually how a web application goes from development to deployment. I'll be explaining everything from the fundamentals. So, even if you are completely new to web development, you should be able to follow along. Before we start learning HTML, CSS, JavaScript, databases, or backend programming, I want you to first understand something very fundamental, like what actually happens when you open a website. For example, suppose I open any browser, take it as Google Chrome, Brave, Mozilla Firefox. What happens when you type Google or any website? Let's say, for example, youtube.com, and press enter. So, what happened between the moment the website appearing on my screen? So, most people simply think that I typed the website address and the website appeared or opened in the tab. But actually, quite a few things happen behind the scenes. The browser needs to find the computer where that website is hosted. It needs to communicate with that computer. The server needs to process your request or our request. It may need to retrieve information from a database, and finally, it needs to send something back to a server or, sorry, in the browser. So throughout this session, we are going to build an understanding on this entire journey. By the end of this video, you should be able to look at a web application and understand the major pieces behind it. Browser, DNS, front end, back end, API, databases, HTTP, and version control. And once you understand these fundamentals, learning individual technologies becomes much easier. So let's start. Uh, the first time the website or the World Wide Web got into this word was in 1989. So it's like almost 27 years ago. So before we go into the website's work, let's quickly understand where the web came from. There is an important distinction that beginners sometimes miss. That is, we often use the terms internet and web interchangeably. You might have heard some person saying, "No, I'm browsing on the web, browsing in the internet." They are not the same words. I mean, they are not the same words, but you need to understand the basic difference, the fundamental difference between them. Technically, they are not the same thing. That's the first thing. The World Wide Web, or simply the web, is a system of interconnected resources that operates over the internet. Let me phrase you another way. The internet is like an infrastructure, the roads, highways, network connecting different places. The web is one of the services that uses that infrastructure. Email uses the internet, online game uses the internet, video call uses the internet, and websites and web applications use the internet. Now, the person most commonly associated with the invention of the World Wide Web is Tim Berners-Lee. Tim Berners-Lee proposed the World Wide Web at CERN. I hope you heard the word, the abbreviation of CERN. So CERN is where the Large Hadron Collider is located. So the God particle, anything related to physics might be you. If anyone has pretty much interest in the physics, you'll get to know that what a Large Hadron Collider is. So there, this was developed by Tim Berners-Lee. So three technologies are particularly important in that original idea. So the one is the HTML, URLs, and HTTP. So HTML describes the structure of web documents. Consider that is similar to skeleton. And HTTP provides the communication mechanism for transferring information between a client and a server. So if you are going to operate, you will be the client, and the web application that you're going to see in your browser will be the whatever the data which will be shown from the server. So even though today's web is dramatically more complex, some of those fundamental ideas that was done in 1989 is still the same. It is the heart of what we are doing right now. So how has the web evolved? The web evolved into three stages. The one is the static pages, and then came the dynamic sites, and the third one was the web applications. So the first one, as the name itself says, that static pages. For example, websites were primarily built on static pages. If I have to tell you an example, if any of you have watched any movies, Hollywood movies, be it Hollywood movies or Bollywood movies, um, in the period of 1995 to 2002, 3 kind of a thing, in between that period, the pages used to be the way if they showed you, oh, it's an internet, it's on web. So if they showed you any page, the page contained a static look. If you open something, it would show information. It was not like interactive. It will be taking an input or something like that. In most of the cases, I'm not telling every web pages was like that. So websites were primarily static. You would visit a page, read some information, maybe click a few links, and more to another page. The content didn't change. It was very much based on what we were doing at that period. For example, imagine a simple company website that contains about us, our services, contact us. These are the places, or these are the links there where you will be seeing a static information. There wasn't much input or output given and taken from any of the end. You visit the website and read that information. That was very simple example of a static website. Then the web became much more dynamic. Websites started communicating with databases and generating content dynamically. So what does this dynamically and generating content mean is that, think about an online shopping website. So this was the nascent phase of Amazon. We all know we have all have ordered something on Amazon. See, I'm particularly talking about Amazon because this was the phase that Amazon got started. If I'm not wrong, it was started in 1995 or 1997. At that period, it was like they weren't selling everything in the Amazon. They were particularly selling books. At least that what I heard from Jeff Bezos, the founder of Amazon. So after a period of time, the dynamic uh, part was added to the web pages. So here what happened was, when you open Amazon, the products you're seeing aren't simply hard coded into an HTML file. So I'll come back to HTML file, like how the design or how we are going to put information in HTML file. So the application can retrieve products from the database when you are browsing in Amazon, determine which products should be shown to you, and generate the response dynamically. Let's say you are looking for something related to toy, for to buy to your children or your nephew, niece, or any small kid, or if you want to play with them. Actually, I still play with them. So this was in front of me. That's why I took an example of a toy. So if you open something related to Hot Wheels, and you'll get to see the recommendations related to the toys, like especially cars. So you'll get recommendation. Like how did Amazon got to know that what you're looking for and your interest on the thing that you are browsing in the catalog of the Amazon. So this is what the dynamic part is. And after that, we move to the part where web applications is being served to us. So web application is one you can say that it extensively requires internet to work. It doesn't simply show you something static document where in this web application you can type, edit, collaborate with other people. Let's say take an example of Google Documents. So where you can edit the file, you can create a file, you can share the file, you can receive updates and interact with the application without constantly refreshing. It will be happening as we are on the go. So you don't have to save control s or anything like that. It will be happening on the moment. So that's why modern web development involves such more than simply creating a simple HTML page. Uh, and that's that related to the evolution of web pages. Now let's move on to the next. What happens when you enter a website address? So when you enter a website address, what actually goes behind everything? So let's get into the most important part of the session. Like suppose I open my browser and I type example.com. That would be a appropriate example to type and press enter. The first thing we need to understand is how does the browser knows where example.com is. Like if I have to give an uh, live example so that we can all understand. Earlier, we used to have this book called Yellow Pages. So in the Yellow Pages, we used to have each and every person's phone number in it. Let's say you want to search a name called Rahul Singhania. So what you would do, you didn't have his contact number. So what this Yellow Pages has this set of names and their address, and not yeah, even address also they used to have, and along with them they used to have phone number printed on this book. So you'll go into the index, like go into the R section, RAHUL, and there'll be multiple people calling Rahul Singhania, and you'll keep on calling until you have hit the right person. In the same way, like when you type example.com, the browser doesn't know who is example.com, what is example.com. So it needs a Yellow Pages kind of a book. And in our case, that would be DNS. Let's say I'll come to it. Like what DNS is. DNS basically stands for Domain Name System. Here what the process is like I gave an example called Yellow Pages, right? So Rahul Singhania was the name and the phone number was the mode of data that you would be using to communicate with that person. In the same way, example.com is the name. In order to get the information from them, you the IP address that you are seeing here 93.184.216.34 is like a phone number. Please consider this the analogy that I'm giving you as an example. That won't make any sense if you put that into the real picture. So try to get the analogy. Uh, so let's say I type the google.com or youtube.com. The computers, while communicating, they doesn't understand what example.com, google.com, youtube.com mean. Their only source of communication happens via the IP addresses. For example, a server might have an address that looks something like 93.84.216.34. Obviously, remembering that IP address for every website, we would be extremely inconvenient. Let's the example I took, Rahul Singhania's phone number, to give the number in our memory is I mean, it is achievable by human, but not with everyone. So everyone cannot be I Isaac Newton, right? So yeah, for this convenience, we're gonna name it and we're gonna hide the IP address behind that name so that it would be easy for us to and the easy and convenient for us to remember that name instead of the IP address. So yeah, as I told you earlier, DNS stands for domain name system. So you think of DNS as a kind of phone book or a contact system for domain names, and we are going to provide a convenient name. So there you have to choose a name for it, a convenient name. Let's say you are selling laptops, so you would name your website as isellaptops.com. So that would make sense, right? So DNS helps us find the corresponding IP addresses. The browser then use that address to communicate with the appropriate server. Now, DNS is actually more sophisticated than simply asking one central computer. So it's distributed involving DNS resolvers, servers, caching, and different levels of DNS hierarchy. So, but for now, since this is a fundamental class, the important idea is domain name is given and the DNS is going to resolve it and give the IP address for that domain name. So once the browser knows where to connect, we can move to the next step. Here, what we are going to see or learn is client and server divide the work. So client is the one, the person who's going to get the information, and the server is where your web application is being hosted. So let's now introduce two terms that you are going to hear constantly in web development: client side and server side. The client is usually the application being used by the user. In our case, that's commonly a web browser such as Chrome, Firefox, Edge, Brave, to name a few. So basically, if I say I'm a client, then in from computer perspective, it won't see you as a person. It will see you as a web browser who will be browsing in the internet. The browser displays the interface, collects user input when we type in the keyboard, and executes client side code. If I have to be more, if I have to give another example, uh, let's take an example of where you go into a hotel and you want to order something to eat. So the order that you are going to give is something similar what you are going to type in the browser. The server, the cook, or the chef on the other side, on the other hand, is the remote system that process your request and give back you the order that you have ordered to eat. The same thing happens here. And I'll give another original example. Imagine you're logging into a website. The browser collects your username and password, but the browser shouldn't simply decide, yes, this is the correct password, this is the wrong password. How can it make that distinction that you are the right person? So this would be checked in the client, I'm sorry, in the server side. So this is what going to happen. The client side is going to take the request and the server is going to deliver what you had asked for. The server can apply business rules, authenticate the user, communicate with the database, and determine what should happen next. So, a very simple way to remember this is client is equal to where the user interacts, and server where server side processing happens. And these two communicate over a network. So this is the part where will be distinguish who is the client and who is the server. Let's moving ahead. We have the front end technologies build what users experience. So yeah, since presentation is everything, people will be judged on how they wear, how they talk, or basically appearance, not how they talk. We will quickly come to a conclusion that, oh, if they are dressed very smartly, then we will definitely gonna say that, oh, he's a good person. If they didn't give a damn about the clothes, then you would definitely gonna judge It depends on the person. So yeah, so as the saying goes, beauty lies in the beholder. So that's the thing. Okay, coming to the topic. So yeah, presentation matters a lot. In this period of AI, where the front end is being developed, such a what can I say, sharply, fastly, quickly. There is no limit on where to put a cap on the presentation. Every day, everyone is breaking the barrier. So here, when we come to web development, front end matters a lot. Here, three things come into the picture. One is the first one is the HTML, and the second one is the CSS, and the third one is the JavaScript. Uh, yeah. So if I open a website and see a heading, buttons, forms, menus, and animations, all of that belongs to the user facing side of the application, right? The user, you, whoever is sitting in front of the browser will see that. Three technologies are fundamental here, as I said earlier: HTML, CSS, and JavaScript. Let's understand them separately. First, HTML. HTML stands for Hypertext Markup Language. I hope everyone has learned this in their school computer classes. If not, then you have come to the right place. So basically, HTML stands for Hypertext Markup Language. HTML provides the structure of a web page. For example, I can use a HTML to create a heading. The one you're seeing your front end technologies build what users experience. This is a heading. This could be created in a web page. That will come under. So let's say I'm going to write a heading as welcome. In between H1, that would be considered as a heading. I can create a paragraph, I can write an image, create an image, I can create a link, I can create a form, I can create a button. So HTML is primarily about the structure and meaning of the content. Um, and then we have the CSS. CSS stands for cascading style sheets. The cascading, what does cascading mean? Basically, cascading means water falling from uh, what can I say? I'm picturing it. Cascading means water falling on a fall, waterfall, cascading effect. So yeah, I'll tell you. CSS controls how that content looks. For example, what color should the button be? How much space should there be between two elements? What font should we use? Do we want to use San Comics? Do we want Abios? Do we want to use uh, Roman? What's that? Roman. Uh, I'm not able to recall the name of the font. So there are many font we can think of. Should the layout change when we are using a mobile phone? There are things CSS helps us control. And then we have the last one, the JavaScript, which dictates the behavior of the uh, what happens when you click on something. JavaScript allows us to add behavior and interactivity. For example, when I click this button, something should happen. Maybe a menu should open. Maybe a form should be validated. Maybe data should be loaded from a server. Maybe the page should update without reloading. That's where JavaScript comes in. A simple analogy is HTML gives the structure, CSS controls the appearance, and JavaScript controls the behavior and interaction. Uh, this is one common example that everyone takes, that HTML is like a skeleton, CSS is like the body that we have, the muscle, the skin on it, and how we look, and JavaScript is like how and what this body can do and what happens when we fold our hands, open our palm, lift our hand, what happens. So this is what JavaScript is going to do. Yeah. So this is about the front end technologies, and moving ahead, we have the back end technologies. Uh, Run rules and protect data. So the next slide is about back end technologies. Now let's move behind the screen. The one we have looking at the front end. Now we will come to the back end. Suppose I'm using a shopping application. Let's say Amazon, Flipkart, Snapdeal. I hope people remember Snapdeal. I see a product on the screen. I click buy now. What happens next? The front end needs to communicate with some backend system. The backend is responsible for things such as authentication, authorization, dictate the business logic, processing request, accessing databases, providing APIs, logging, and security related operations. Much more will be handled from the backend. So there are many technologies that can be used to build backends. For example, we have Node.js. We have Python frameworks such as Django, Flask, Fast API. We have, sorry, a Flask. When it comes to the Java, we have frameworks like Spring Boot or Spring. When we are using old PHP frameworks, then we have Laravel. There isn't one programming language that is automatically the best for every backend application. The technology depends on the requirements, existing systems, performance needs, team expertise, the team members who are in your team who are good at what they are good at, and the ecosystem that you are going to connect each and all. And many factors will be involved, and these are some that I can name. The important thing at this stage is not to memorize all of the technologies that I named, and to pin out that this is the best technology and I'm going to learn this. So there's no best technology. It all depends on the requirement and the things that I said earlier. So yeah, uh, instead understand the role. The backend process requests and implements the application's server side logic, right? So that's what going to happen in the, moving ahead, we have the databases. So yeah, as the title or the heading of this um, slide says, that databases preserve information beyond one session. So SQL, no SQL, to be or not to be. So now we have another important question, like why we have to use database. What's the use of it? Let's say thousands or millions of users are using our application that you are built. Where do we store their information? That's where databases come in picture. Information in the sense that not username, password. So all the things that is going to generate the data about the uh, specific person. Where do we store the information? There we have the answer, the database. So a database allows applications to persist the information that it's going to generate or has created. For example, an online shopping application might store users, products, orders, payments, and then what? Addresses of the person that is going to order, reviews that you write, 1 star, 5 star, 3 star, no star, and many other types of information. Two broad categories you will frequently hear about are SQL, no SQL. So SQL databases are relational databases. Like say there is 3 or 5 columns, and each column is dedicated to one thing that will be linked to that column. So this is where a relationship is built. Let's say you are going to find a person called Rahul Singhania, and you should be finding the person in the column of names, right? So that's what the relationship is like. So in SQL, there's examples of SQL are PostgreSQL, MySQL, uh, and best fit structured data transactions reporting. Basically, this would be what we are going to use SQL databases for. Data is generally organized into tables. For example, imagine a user table so that I just gave name, ID, email, etc., will be filled against that table. So we can have another table for orders and another table for products, another table for addresses, something like that. So the tables can have relationships with each other and one another. This relational structure is particularly useful when we have structured data and relationships between entities. It is also very important that we need reliable transactions. For example, think about a banking transaction. If money is transferred from one account to another, we don't want the database to update one side successfully and somehow fail on the other side while leaving the system in inconsistent state. So yeah, so let's say you send some money to a person and you say that, hey, I've sent you the money, please check in your account. If their side, their account is not updated, then they will be like, oh, you have not sent me the money. What the hell, man? Why are you lying? So trust issues is going to come up. So this is where the consistent database entry has to happen. There's one reason transaction support is so important, and that's what I just explained. So now let's talk about the other part, NoSQL. So flexible models for different access patterns. So this is quite flexible. There won't be any structure. There won't be any relation per se. Uh, it is not like if I have to give an example, like not example, if I have to give an explanation to it. One important thing to understand is that NoSQL isn't one specific database. It's a family of different database models. For example, we have documented databases. MongoDB is a popular example. Instead of thinking primarily in terms of rows and columns, that the table that we had talked earlier in the case of SQL, we can store document like structures. We also have a key value databases. So if someone have gone through HCD in Kubernetes, they'll understand the key value pair. Redis is a popular example. The basic idea is there will be a key and there is a value for it. Then we have a wide column databases such as Cassandra, which are designed for particular large scale distributed workloads. And we have graph databases such as Neo4j, where relationships are a central part of the data model. So why does NoSQL matter? So since we have a structural relationships that table are created in SQL, why and when we need NoSQL? Because different applications have different data requirements. We may need flexible schemas. We may need a very large scale distributed storage. We may need particular access patterns. We may need to model relationships differently. So that's why NoSQL database exists. It's not about saying SQL is a bad and NoSQL is good, or NoSQL is replaced by SQL. It's not a good way to compare one another, thinking that this is good or bad. So they have their own merit, and the place they have required, they will, they will be fit in that place. So in reality, both continue to be widely used, and some applications use different types of databases altogether. So that's about databases. Now we have come to the last part of the segment, that is the HTTP and APIs connect the two sides. Here, the two sides are the front end and the back end. But how does the front end actually communicate with the back end? One of the most important protocols you'll encounter is the HTTP. HTTP stands for Hypertext Transfer Protocol. Earlier we got to know about HTML, and HTML stands for Hypertext Markup Language. Please don't mix one another. So they are two completely different identity, and they do a different job. The basic idea is that a client sends a request and the server sends back a response. For example, the browser might send something conceptually like get products. Get is what you're going to get, and post is something that you're going to send. So these are two things that you need to keep in mind. The server receives that request. When you say that get products, the server is going to take that request and it process it. Maybe it checks authentication if that's behind something security level. Maybe it requires the database and then it returns a response. Modern web applications frequently use APIs for this communication. API stands for Application Programming Interface. Application Programming Interface. For example, our front end might ask, give me the detail of product 101. The API might return something like in a JSON format. It gives you like the name and the price of it, since it is something related to a product or 101. So this is what it's going to give the a response like. And the format in most of the response would be in JSON format. So JSON is the uh, actually JSON, right? So we also have the name called JSON Statam. You might have known the transporter guy. JSON is a very common data format used for exchanging information between application. So you'll see JSON everywhere in modern web development. And if you're using PHP, you'll also hear the term Ajax. So historically, as Ajax referred to the technique of using JavaScript to communicate with the server asynchronously without requiring the entire page to reload. Let's say there is a content that you're viewing in a web page and you click something, and the reflection and the response that you will get will be shown in that particular box. The whole page won't be reloaded. The whole page won't be considered as a static one page. If you want to change something in that page, a refresh has to be done. So Ajax fixes that thing, and it works asynchronously. Today, developers commonly use APIs together with JavaScript's fetch function and the other tools to accomplish this kind of behavior. So when you see a web page update, its data without completely refreshing, there's a good chance some form of client server communication is happening in the background. So for this session, we will wrap up till the HTTP APIs. In the next session, we're gonna take up the further. Thank you so much, guys. Thank you so much for watching this video and supporting me. Thank you.